Yeah. Okay, so make sure you have a highlighter because I'm going to highlight quite a few. There's a lot of concepts, not a whole lot of math. I mean, you do, but it's just adding, subtracting kind of stuff. You just need to know what is what. Okay. So let's go to page 81. So I'm going to skip a whole bunch of pages. We're going to go straight to page 81, and we're going to first talk about accuracy. And okay, there's accuracy, page 81. In everyday life, people often use words like precise and accurate to mean the same thing, right? In mathematics and trades, however, they have different meanings. So being precise and accurate, we're going to have different meanings. You can highlight this. This is basically sums up accuracy. Okay, how close the measured value is to the true value. Page 81, Nikolai. 81, page 81. Did you grab the booklets on Friday? You have the booklets from Friday. 1 each, yeah. So if we have a piece of lumber and it's supposed to be 8 feet, like that's what we know as 8 feet, and you measure it and you get like 7'11" or something like that. You're right. You're not quite there, but you're close. Right. So accuracy. I will just have accuracy. To be accurate, this is the key here. To be accurate, a measured value must be as close to the real value as possible. Okay. Someone should be able to repeat the same measurement and get the same value as you. That's when you know you're accurate. Okay. Accuracy can be affected by two things. Okay. This whole thing is important. I will ask that in some way, shape, or form. And it's kind of like a story, a bit of a story there. Improper or careless use of the device, or it could be that the device you're using is damaged. Okay. So for example, improper use of a measuring device. If you're baking and you're scooping something moist with that cup and then you go and get some flour with it, like it's gonna stick to the sides, right? I know it's not a big deal. I know in cooking it's not a really big deal, but it does affect the amount of flour you're gonna be grabbing, right? And so that would be, or not like skimming off the top. Like if your spoon is like this much flour over it, you're supposed to like skim it off and just, right? That's a tablespoon or a teaspoon, right? And so you wouldn't be using it properly if you didn't do that, right? Damaged measuring device. What I'm thinking is if you have like a plastic ruler, right? This isn't, yeah, I think it's plastic. If you leave this outside for very long, it's going to warp, right? And so it's not going to be perfectly straight anymore. So it could affect your measurement from then on. So that's another example of, so then either one of those would result in inaccurate measurements. So here's what I want you to add, okay? To be accurate, I look specifically for two things. Okay. First one is unit of measure. Is standard. The unit of measure is standard. So what am I talking about? I'm talking centimeters, inches, milliliters, centimeters cubed. Anything that is like you can recognize, okay, that's an official unit of measure that I've learned about. Hey, you're late, but do you have a booklet? No. Take one of each. And so we want the units of measure to be standard, okay? None of this like hand span or elbows or steps, that's not standard, okay? The next thing you want to watch is for scale. Scale should be appropriate. It's a bit slanted, right? Scale, right? So unit should be standard and the scale should be appropriate. So you shouldn't be using centimeters to determine the distance between two cities, right? Centimeters just wouldn't be a good scale. Kilometers, miles, now we're talking, right? Maybe meters, hundreds of meters, like towns could be a couple hundred meters apart, that's fine, or yards, but not centimeters or millimeters. So it just wouldn't fit the scenario, right? If you're trying to measure the diameter of hair, right, then you're going to go really small unit, right, a much smaller unit. So the scale should match what you're measuring. How's that? So this is so important. I'm going to box this in. And I will also box in the top that I highlighted here. Those are two things that I would say make sure they find their way into your study sheet and try to compress it. Like for example, to be accurate, unit, scale, maybe just a little thing to remind you, right? Explain if the following measurements would give an accurate measure. And if the measuring device is appropriate, state why or why not. So in each one of them, we're going to determine two things. We're going to look at unit, and we're going to look at scale and see if they both have to pass for you to be accurate. Okay, so for the unit, it says using the length of your forearm. Using the length of your forearm, right, to measure a picnic table. So this is the units, right? Units are not standard. And the scale, using the length of your forearm to measure a picnic table, it actually is a decent scale. Okay, so the scale is appropriate. So this fails, this passes, but we still say therefore, the three dots like that is therefore in math, not accurate. And why is it not accurate? It comes back to, I'll keep that on there. Let's see. Read where my pencil is. Someone should be able to repeat the same measurements and get the same value. If I measure a picnic table with my arms and then somebody else comes along, there'll be a different measurement, right? My forearms are probably a lot longer than most people. So you can't like, and yours differs from somebody else, right? So repeating that will not be possible. It would be very difficult to get the exact measurement. So that's why if it fails, if the units are not standard, it fails. It's not accurate. Next, using the length of your stride to mark off a soccer field. So we'll talk about the units and we'll talk about the scale. And the units, because it's the length of your stride, again, it fails. That's not a standard universal way to do it. Soccer field, let's see the first one, units, not standard. So it fails. Scale, it is appropriate. Like I've done that, like you've done that if you play volleyball or something, or a soccer field, you kind of want to like see how wide and how long should we make the field. You probably take a few steps and and get it done, right? So the scale is appropriate, but it's not accurate. Therefore, not accurate. So fail so far. Using a meter stick. Oh, a meter stick. To calculate what? Distance between two cities. Now this is where you get into a gray zone. Okay, but I'll talk units and I will talk scale. Units, is it standard? Meter stick is standard. A meter stick is the same no matter where you go. So you will be able to repeat that measurement. Unless you don't know how to use it, right? If you measure something like this, right? Like you measure the distance like this, obviously you'll be off, right? So that's another story. But other than that, it's standard. Okay, it's a meter basically, right? And scale, what would you say? It's technically inappropriate, right? Not appropriate. Too small. Therefore, so it checks the units are good, but the scale is not. We still say not accurate. In math, that is in math, okay? Then next, a ruler marked in millimeters, that's standard right there, to measure the width of the book. What do you think? The units, standard, we're talking millimeters. And the scale, I think it's not bad, right? The width of the book in millimeters, I think it's not bad, right? Appropriate. So check and check, therefore accurate. This, by our definition of accuracy, would fit the bill. That would be an accurate measurement. Somebody could measure it, somebody else could measure it and get the exact same result because we have the standard unit and the scale is pretty good. Okay. So that's that. We're gonna This is accuracy. Now we're going to talk precision and uncertainty. We're going to spend most of our time talking about that. Okay. Make sure you have a highlighter and make sure you add the little tips that I'm giving you as we move along. So at first it's a bit dry, but then later I will give you ACs where you have to like figure out and calculate things. But it all starts with concepts, right? So go to the kind of like where it says precision and uncertainty on page 82. Precision and uncertainty. Now, I have to warn you, a lot of us, if I talk about some of these things, you'll be like, what are you talking about? I don't worry about uncertainty and precision. Like I don't think of it that way. But it is a thing in industry. Like they actually made us teach this unit. Like Manitoba is the only province that has this unit in it. Because they were saying that a lot of students, they go and work for factories and they have no concept of precision and uncertainty. But really, when you're working in a production or a factory, you're constantly checking, right? Like when you're producing something, you're checking like, is this pretty good? Is this accurate? Is this precise? Am I allowed to be off by a little bit? And so they wanted this in there. Actually, it's the companies that asked for this unit to be in the curriculum, right? So it is there for a reason. I will read through it. Like accuracy, precision is related to exactness as well. But this is the key here. It is determined by the limitations of the measuring instrument. Okay? Precision is determined by the limitations of the measuring instrument. For example, if you're measuring a device, if your measuring device is marked off in centimeters, that is as precise as you can measure. Your answer will be to the nearest centimeter. Okay. On the other hand, a measurement made with a ruler marked in millimeters, right, would be more precise because the ruler is marked in centimeters. It has a smaller, you're able to be more accurate that way. So let me give you an example. This meter stick, okay? If you look at it from one side, right, you can tell it's metric. It goes up by a centimeter, right? If you wanted to measure this pencil, for example, right? It's just past, let's take the lead in. I put the lead in there. So we are just past 15, right? 15 centimeters. Based on this ruler, we kind of have to round it at some point. So you'd have to say it's 15-ish, right? You would say it's about 15. But you could be more precise. Watch this. Let's flip this over. You see the smaller markings there? This is a lot more precise. You're able to narrow it down a lot more. So you actually, if you wanted to, that's 15.1, right? See that? 15.1 centimeters or 151 millimeters. But this is more precise because this is marked in millimeters. This is marked in half a centimeter increments. Even though the only numbers that appear are centimeters, the markings are half a centimeter at a time. Right? So this is a perfect example of precision. This ruler, if you had two rulers, this would be more precise than this one, right? And that's just how it goes. Let me give you another example. I'm going to use the scale. Lucas, you might have to turn on the light for me. Hold on, we'll give it a try. Because this one doesn't always work very well with the screen. Can you try turning on the lights once? I'll just get it right here. Hold on. Can you see the numbers? Hold on there. You can see the 0, right? So if I take this clip, we have 25 grams, right? 26, sorry, 26. So 26 grams, that's as close as it can get. Do you think there's a chance? Oh, it's gaining weight. It's like me, right? 27. Do you think there's a chance that this clip is 27 point something? Is there a chance? There is a chance. But you can't. This thing is limited. Like it can only give you to the nearest gram. It can only, like if I make it a little heavier, oh, 28. Right? Like it can't do in between. It's limited to the nearest gram. But if I change this, no, that's not what I wanted. Sorry. I can change the unit, watch. This is technically the same precision, but right, this one is in kilograms, right? It goes 0.027, right? And this would have a precision of 0.001 of a kilogram. Let's change the units to pounds and ounces, right? It's about 1 ounce. It's flipping between 1 ounce and 0.9 of an ounce, right? So every device, whether you like it or not, is limited. Your car, the odometer reading, right? It will flip every once in a while, right? Every 100 meters, but it won't go every meter, right? So it's kind of limited. At one point, you will just see what the rounded value is. So every device has a limitation. One last example. Tomorrow, if I think of it, I'll bring my voltmeter to measure current and electricity. Watch this one here. Let me see. This is going to be tough to focus. I know that. Hold on. Oh, that's as good as it's going to get. This is, right, a thermometer for barbecuing, right? Look at the Fahrenheit. What does it go up by? 10 degrees Fahrenheit, right? You're guessing, right? If the needle is somewhere in between here, you are guessing. Like you are kind of saying it's between 180 and 190. Obviously, we can make an assumption that if it's in between, then it's 185. But other than that, this device is limited, right? It doesn't give you a whole lot more. So every measuring device has its limitations. Okay. Thank you, Lucas. Yeah. Go ahead. So let's keep going here. So precision is one part, and watch this. There's the uncertainty. Because of the limited precision of the measuring device, there is always some uncertainty. Highlight that. Okay? And I will give you this, I will ask you to do that, the following here. Uncertainty on the side here, you see that little box there on the side? It's the margin of error, like how much you can be off by, right? And uncertainty is half the precision. Make sure you highlight that. And I will box both of these in on the side here, right? So if you want a good definition of uncertainty, it's the last unit, guys. You can do this. Okay. Precision is the smallest unit of measurement. Okay. And uncertainty, I actually want you to really focus in on this part. Precision, right, or uncertainty is half the precision. I'm going to give you some examples. State the precision and uncertainty of the following. F like that is following, okay? Let's put it to the test, like our knowledge here. So let's say you see a measurement and it says 6 feet 2 inches. Another measurement here, it's 185.19 grams. And a third one, 3.5 liters. For every single one of these, I want you to state the precision and the uncertainty. Precision and uncertainty, and that's going to be, you're going to have numbers there. Okay, I'll tell you this, precision is always going to have a 1 somewhere. Always going to have a 1 somewhere. So watch this. If I look at this measurement, I am assuming that this device that has been used can get me as close as possible to the nearest inch. I'm just assuming that because I don't know what has been used to come up with this measurement. So my assumption is that this device is as close as possible to the nearest inch. Okay. Let's do this one here. What's the precision of the device that has been used to come up with this measurement? And the answer lies here. The last decimal place. And you count how many decimal places is that, right? 1, 2, 2 decimal places. So your precision is to the nearest 100th of a gram. It's that second decimal place is where the action is at. And what you're saying is that this device could go up by 1 or down by it could go up by 0.01 or it could go down by 0.01 at a time. That's the limitation of this device. It can't give you anything really in between. It has to go up by 0.01 or down by 0.01. Let's look at this one here. 3.5, right? You focus in on that, and it's 1 decimal place. So then you go ahead and put a 1 in for that decimal place there. And it's always the units that you are given to begin with. So notice they all have a 1. And it always was based on the smallest unit. In this case, it's 6 feet 2 inches. We all know inches are the smaller units. So it's to the nearest inch. This device allows you to get as close as to 0.01 of a gram. And this is 0.1 of a liter. Go ahead. So that's all you can do. Watch this. How do you get the uncertainty? Careful here. Uncertainty is what? Half of the precision. So we're going to go 1 inch. We take the precision, divide it by 2. So you get 0.5 of an inch. Right now it's nice and easy, but there's going to be some curveballs, okay? We take our precision, we divide it in half. What do you get when you divide 0.01 in half? Right, 0.01 divided by 2. Watch how many zeros there are. It's very important. 0.005 of a gram. That's the uncertainty. That's by default what we think that we're off by potentially. And then 0.1 divided by 2 is 0.05 of a gram. Okay. I will break this up like this. Okay. So break it up into chunks. So I don't know if you want to go arrow from here to the inch. And we went arrow to that second decimal and to the first decimal, right? And I will make a note underneath it. Close that there. I'm trying my best to make this that you can grasp it, okay? Note, we were not given the actual measuring device. i.e., we go by the measurement. That is very important to understand. Because if you are given the measuring device, you're going to go by the device. Okay? I'm going to highlight that. Okay. We're not given the actual measuring device. In other words, we go by the measurement. Like the measurement is all we have. So we're making assumptions that this device is precise to the nearest 0.01 of a gram. Okay. We're on page 82. And so how did I get my uncertainty? I divided it by 2. So I'm actually going to, every single time, I divide my precision in half. And that's my uncertainty. You're kind of saying, it's close to the nearest inch, but I could be off by half of what the limitation is of the device. So you will see how that gets added to your measurement later. I'm going to continue here. It is often necessary, right? It is often necessary to record how much uncertainty exists in a measurement. Unless stated otherwise, here it is again, uncertainty is half of the precision. Okay, so I'll put this, uncertainty is just precision divided by 2. We're not going to use the box example above. We're just going to stick with what we're doing here. But this is worth highlighting as well. Measurement uncertainty, okay, measurement uncertainty can be written as follows. I want you to box this in. Measurement uncertainty has the measured value plus or minus the measurement uncertainty. And here is where it branches off. From this, you can get the max, make sure you write this down, and you can get the minimum possible values that are there. The max is measured value plus uncertainty. Okay, and the min is the measured value minus uncertainty. Also box these in. And watch this, I'm just going to add this if you can. There's something called the range. The range is the difference between these two. This is the gap that exists between the maximum and minimum possible amounts or values. And I will give you the range here. Range is simply taking the max and subtracting the min. Range is max minus min. Okay. And I will I'll just leave it at that for now, but all of these boxed in items should be on your study sheet as well. So when you have your pop can, how many milliliters are there usually? 355? It could be more, it could be less, technically. If we were to measure every single one, you would not get 355 every single time. It could be off by a little bit. And so that's what the max and the min is. You could have probably, I don't know, depending on the uncertainty, you could have 356 milliliters, you could have 354 milliliters of pop in there. If you board a plane, they weigh your luggage every time, right? If you're overweight, what do they tell you? You gotta either remove or you gotta pay extra, right? There's a penalty. And so they need to know exactly how much weight goes on that plane. And so every bag that they weigh, there's a little bit of uncertainty, right? They might be off by a little bit. Can you imagine 200 passengers each having 2 pieces of luggage that go onto that plane? Every single one is off by a little bit. They very much take that into account, right? They know that, and so obviously they're not going to max out on their weight capacity because of that uncertainty that exists. Okay, let's go to our example here. State the precision and uncertainty of the following measurements. And you're like, okay, a ruler marked in millimeters. Can you please highlight that? Because that is so key. A ruler, if it tells you the markings, okay, that is the precision right there. Let's write precision over that. If it doesn't matter what else happens, if they tell you what the markings are, hint, hint, that's precision. So my precision, if it's marked in millimeters or marked in quarter millimeters or whatever, in this case it's marked in millimeters, we know that the precision of this ruler is to the nearest millimeter. And that's how I came up with that. That's how I came up with that. And what's uncertainty, guys? How do I get my uncertainty? It's just divided by 2. Your precision, once you figure that out, half of that is our uncertainty, so 0.5 of a millimeter. And I want to use this example to show what I just did up there. I want the measurement, write this down, measurement uncertainty. What if the question says, give me the measurement? We'll do this, plus or minus. Measurement plus or minus uncertainty. If I give you this exact picture, and I asked you, hey, give me the measurement and its uncertainty, this is what you do. What is the actual measurement of this? You try to get it as close as possible. It's 62 on the nose, right? So you would say 62 millimeters plus or minus whatever the uncertainty is, which we figured out is 0.5 millimeters. And that is all you need to do there. Add the plus or minus. And the uncertainty is there. Okay. So you go measure it like we got from here, we got the measurement, which we determined to be 62. You might have to round. You might have to say, well, I think it's about 62. I won't be too harsh on you if you get it off by a little bit, but it has to be as close as possible. But then the uncertainty, I got it from here. Where did I get my uncertainty from? From the precision. Where did I get my precision from? In this case, it told me what the markings are, and that is the limitation of the device. You're probably super excited about what we're learning, right? I know it's a bit dry, okay? But just follow me and it'll be fine after a while. An odometer records the distance traveled to the nearest kilometer. That right there gives me the precision. In this case, the odometer can only go to the nearest, right? Nearest kilometer. And my uncertainty is just half of that. So we take that, we divide it in half to get me my uncertainty. That's all you need to do there. It doesn't tell you how far you actually traveled. It just tells you what the limitation. This is the limitation. Okay. Limitation is also what precision is. Okay. The outside temperature was recorded as right there, guys. Highlight that. A measurement is given. This focus in on the last decimal here. That's where my precision comes from. And don't worry about what's to the left of the decimal. Just put a 0 point, and in this case, it's 1 decimal, right? So you got to go 0.1 degrees Celsius. Can I just add, because I know some of you will put down 0.5 tomorrow on the AC because you remember me pointing to the last digit. But there's always a 1 that you place in there when you talked about precision. Why is that? Because technically, if the temperature dropped a little bit, it could be down to this. If it went up a little bit, it would be showing you this, right? So you're saying that the change from one temperature to the other can go by 0.1 at a time, okay? So the uncertainty is Divide this thing by 2. It's 0.05. There's a pattern. Just take this, divide it by 2, and you get 0.05 degrees Celsius. So, in this case, slow down, Mr. Dixon. Write this down, okay? In this case, a measurement is given. You can write it like this if you want. So you could say the temperature outside is 12.5 degrees Celsius, plus or minus. You figured out your uncertainty now. Right? This uncertainty, once you know it, and once you know your measurement, you can write it like that if I asked you for it. Just watch for the question, like what is it asking me for? Technically right now we would have been done here. This is all it's asking for. But you should be prepared to do that. Harpreet says it took about 5.25 hours to drive from Vancouver to Kamloops. Question. Do they give you the measurement device? Like what has been used? Was it his clock? Was it his iPhone? What was it? We don't know, right? So then all we have is this. So we focus in on that last digit. So my precision is 0.01 because there are 2 decimals. So it's 0.01 of an hour. That's how precise that device is that has been used. Okay. Uncertainty, just divide that in 2, you get 0.005 of an hour. Okay, 0.005 of an hour. And because there's a measurement, you could now say it took 5.25 hours plus or minus 0.005 of an hour. We have our uncertainty stated there. Okay. So it goes from measurement, gives me the precision. Once I have the precision, I split it in half, and that's my uncertainty, right? And the uncertainty is what I state next to the measurement. This is the limitation. Because of the limitation, we are assuming that half of that we can be off by. Okay. Can you highlight this part here? The smallest unit on the measuring device determines the precision. Okay. Sorry, you can't see that there. Markings is another one you need to watch out for. Markings, like when it says marked in fill in the blank, that is your precision right there. Okay. Let's give this a try. So go to page 84. I want you to try all of 84. Question 12 is a little tricky because it's imperial, but I need to have one example like that. Yeah, just make it quick. 84. And if you can go to 85, go ahead and do that already. So remember, it's asking you for precision and uncertainty. And right now, let's say you get it all wrong, big deal. Just give it a try. Just give it a go. How do I know? I need to go back to my notes. Go ahead and do that, right? And I will I'll hand it back to you here. So go to 84. The hopefully by the end of today, you have a pretty good grasp on all those things, especially precision and uncertainty. Okay. Runa is using a meter stick, and it's marked off in centimeters. That is huge, right? I will actually ask you to circle that. Right? Precision is given by the short little statement there. The length of the classroom is to be measured. What's the precision and the uncertainty? The precision, if it's marked off in centimeters, it's saying to the nearest centimeter, to the nearest 1 centimeter. And the uncertainty is just, right, half of that. And you're done. Okay? Next, the odometer on Sam's car measures distance to the nearest tenth of a kilometer. I don't know if that, right? It says to the nearest tenth of the kilometer. It's saying, like, how close can you get, right? Precision right there. And think about it. Tenth of a kilometer is 1/10 of a kilometer, if you want to put it that way, right? So the precision is 1/10 of a kilometer, but we don't really like fractions that much. So just go divide that as 0.1 of a kilometer. That's basically what I would prefer you stating. And uncertainty is 0.1 divided by 2, which is 0.05 of a kilometer. So there you have your precision and your uncertainty. There were no numbers given, so you got to watch out for markings or indication of how limited that device is. Okay. Next, Taming is a vet nurse measured a dog's temperature to be 38.8 Celsius. What's the precision and uncertainty? This one, you need to look at the measurement, and the precision is right there. It's to the nearest 0.1 of a degree Celsius. So precision is 0.1 degrees Celsius. And so uncertainty is just half of that, which is 0.05 of a degree in that case. So precision and uncertainty is all I was asking you for over and over again. Okay. So measurement given, no measurement given, but they gave you, can I say this? Soon there will be a picture of the device. I will actually take pictures of various devices, and you'll have to tell me what the precision is based on what the markings are on that device. Okay? Determine the precision uncertainty of the measuring device. Watch this. This is tricky, but you need to know this. I should have put down that this is in inches, right? So 1, 2, 3. So you need to count like 1, 2, 3, 4, 5, 6, 7, 8. So you now know that this is to the nearest 1/8 of an inch. That's your precision. And if you don't like fractions, you just go 1 divided by 8, and you get 0.125. I'm okay with you doing that. Just turn it into a decimal like that. Therefore, the uncertainty would simply be 0.125 divided by 2, which is even smaller, right? You're splitting that in half. And do not round in this unit. I should have put it right at the beginning of the booklet. Do not round. This is the one unit we do not round. Use all decimals, okay? Because it will get to the point where you have like 4 or more. Next, state the measure of the string with its uncertainty. So you got to go up here and try to measure it. So the string starts here and goes to here. What would you say? It's 1 and it's closer to this mark than it is to that mark, right? So you'd have to say this is 1 2/8 of an inch, plus or minus 0.0625 of an inch. The uncertainty was already determined earlier. And some of you are saying 2/8, Mr. Dirksen, isn't that 1/4? Yes, you're right. So I kind of ran out of room there, but it's the same thing, 1 1/4 inch plus or minus 0.0625 inches. And if you want to state that as a decimal, 1.25 instead of 1 1/4, I'm fine with that. No big deal. In fact, if you would have divided 2 by 8, you would have gotten 0.25, right? So that's fine. We will forget about C. Don't worry about C. But the next two, I need you to, it won't be very often, but it will show up from time to time. So just watch what it's trying to say here. If you had to go to the nearest 1/4 inch, what's a 1/4 inch, Mr. Dirksen? This is 1/4, 2/4, which is half, 3/4, and then a full inch, right? So if this ruler was marked off in 1/4 inches, forget about all the other ones. What would you have to say for this measurement? Well, between this and this, it's closer to this, right? So it would be 1 1/4 of an inch. What if this ruler had been marked off in 1/2 inch increments? Meaning, start at 1, 1/2, and then another one, right? So it would go up by 1/2 inch increments only. What would this be closer to? 1 inch or 1 1/2? It's slightly closer to 1 inch. So you would literally say 1 inch, right? Closer to 1 inch. So it's giving you scenarios. Imagine this ruler only had 1/2 an inch increments. That's all you have. You have to pick between two numbers on that ruler. You're like, that's silly, Mr. Dirksen. I would have probably guessed 1 1/2 or 1 1/4, whatever. But just kind of try to rewire your brain to think the way they want you to think in this case. Let's keep going. We're almost done, guys. And then you might have some time even to try a few more. Backside here. Make sure you have this example filled in because this is a full-on max, min, range, and all that stuff. Okay. Genevieve is mixing juice marked in 1/4 liters. Very important. That is what? That is my precision, right? Boom, right there. She measures the amount of juice to be 2.5 liters. So this is actually the measured value. Okay, this is the measured value, and this is the precision right here. Okay, write the measurement of the juice in the jug in this form. So they want it like that. I will do that to you as well. I'll say this is how I want it. So 2.5 liters plus or minus the uncertainty. Before you do that, you take this and you say that the precision is 1/4 liters. So you can say 0.25 liters like that. From that, you get your uncertainty. Just divide that in half. So your uncertainty is 0.125 of a liter. And this is what you're going to put in here. Right, 0.125 of a liter. That's what they wanted. They wanted the measured value, which they gave you, plus or minus the uncertainty. So we have to back off because they gave us a marking that gave us a precision. We divided that in half, And then we could insert that into this format. This is how we want our measurement to be stated most of the time. So this is literally saying that it could be more or it could be less than 2.5 liters. Okay. All right. What's the smallest and largest possible volume in liters that could be in the jug? Largest is what we call the max, right? You just go 2.5 plus 0.125. You just add these together. And then the smallest is the min, okay? And that's just simply taking the 2.5 and subtracting the uncertainty. So you're saying it could be more by the uncertainty or less by the uncertainty. So when you get that, when you add, you get 2 point, and you do not round, okay? 2.625 liters, and when you subtract, you get 2.375 liters. So it could be anywhere between these two. And this might appeal more to you because you're starting to drive and you want to speed, right? Temptation is there. When the cops, right, when they have that speedometer pointed at you, there is some uncertainty, right? There is some uncertainty. So they will let you go if it's just marginal, right? Like if you're speeding a little bit over, if it's a 60 and you're going 62.5, they're probably going to let you go because they're like, it could be less, it could be more, it's not worth it. It could be the gun, it could be your tires a little bit oversized. So they just like, whatever, right? Because they know that cars aren't always accurate with their speedometers, right? So uncertainty applies everywhere, really. When a doctor performs a surgery, they need a blood transfusion, there's always going to be a bit of uncertainty, right? How many liters, right? Well, it could be this, it could be that, right? They have a min and a max, so they always prepare, obviously, for having more, but there's always uncertainty. What's the range of volume that could be in the jug? And this is where you just need to remember the formula or have it on your study sheet, right? None of these formulas are at all on your formula sheet. It all has to be on your study sheet. So the range in this case is 2.625 minus 2.375. I just take these away, like I subtract them. And you end up, most of the time, you end up with your precision after all. You end up with your precision. But there's a quarter liter difference between the lowest possible and the highest possible. Okay, let's call it I'm going to stop teaching. So I would like you to try, if you start at 85 at the bottom there and go to 86, it doesn't take very long, guys. You just need to put numbers down. Can I just say one thing? Watch this carefully. I don't like this question very much, so I'm just going to give it away. Notice how the height is in meters, but it's marked in centimeters. So you have meters and centimeters. So just turn this into 175 centimeters, okay? Just multiply the meters by 100 and use the centimeters for your answers, okay?